28, you need to show that DSD data squared is equal to 4a squared sine squared half theta. Okay. So for question 28, you have R equals to, you have A times 1 minus cos theta. Okay. Therefore, you need to find DRD data. So the DRD data means you have A times negative cos theta. If you differentiate, you get sine theta. All right. And then after that, you have to use, now because you know that previously that we have DSD data squared means R squared plus DRD data squared. So you have to find what is this. Okay. So R squared means you have A squared times 1 minus cos theta in the bracket squared, followed by A sine theta in the bracket squared. All right. So you have A squared, you factorize it. All right. Now 1 minus cos theta and also A sine theta. However, if you look at the question that they gave you, they are asking for half angle for sine. So sine half theta. So I don't want cos theta, I don't want sine theta. All right. So I can use the half angle formula here. Now for 1 minus cos theta, I can write this one as negative 2 sine squared half theta. Agree? Right? So you square this plus another one is A squared. Now for this part is A sine theta. A sine theta. So you have A squared sine theta. Sine theta you can use 2 sine half theta cos half theta in the bracket square. So you use the half angle formula in this case. So factorizing the A square. No, I think you better don't factorize first. You just expand first. So you have 4a squared. Then you have sine power 4 theta over 2. The second part you have plus 4a squared. Then you have sine squared theta over 2 followed by cos squared theta over 2. So you have to factorize 4a squared. Then you can factorize sine squared theta over 2. So check what are the balance. So you have sine squared theta over 2 plus cos squared theta over 2, where this part simplify and give you 1. Therefore, you get the answer 4a squared sine squared half theta. So you have proof lah. Okay. Yes. Huh? Okay. So you prove this part already. Then after that, they ask you to find the length of the arc from half pi to 3 over 2 pi. All right. So you know that you can use the formula. So the formula is S equals to the integral of square root of this lah. So you have to remember square root of this 4a squared sine squared theta over 2 d theta. Then you have pi over 2 to 3 pi over 2. Okay. So you check when you have this one, do you get a positive sign or not? Okay. Because for this part, sine squared theta over 2 for pi over 2 to 3 pi over 2. Are they positive or not? You have to check. Actually, just for your information, you don't really have to check because it's always positive. But I'm saying in reality, you should check whether the integral here is negative or positive. Okay? Because, yes? Yes? Someone say something. Okay. So you see, when you have theta equals to pi over 2, that would mean theta over 2 is pi over 4. And then when theta is equal to 3 pi over 2, then theta over 2 is equal to 3 pi over 4. So you see, for the sign, it's always positive in this region. All right. So for this part, actually, you don't have to check. But I'm saying for reality, you should check lah. All right. So for exam purpose, you don't need to check the range. It's always positive. Okay. So therefore, you have s equals to, so you get the integral from pi over 2 to 3 pi over 2. So this is 2a followed by sine half theta d theta. So you integrate, you will get 2a times, you integrate sine, you will get negative cos. So you have negative cos theta over 2 divided by half. So you need to consider the limits pi over 2 to 3 pi over 2. So the answer is therefore 4a times, so I have cos pi over 2. So I swap the limit, pi over 2 go up, 3 pi over 2 come down. So the answer is 4a times, so you check lah, what is this? This is cos pi over 4. Yes?
Could you help to let Xiaoyi hang in?
So you have cos pi over 4 minus cos 3 pi over 4. Okay. Wait, do you get, what's the answer? I think you have cos pi over 4 is actually 1 over root 2. 1 over root 2, or you can say root 2 over 2. So root 2 over 2 plus root 2 over 2. Because cos 3 pi over 4 is negative root 2 over 2. Hence the answer is 4 root 2a. Okay, so that is the answer. Correct me if I'm wrong, or I calculated wrongly. Okay. So any questions so far? So for the polar curve, not many questions lah. So far it came out only, I think, twice. That's all. All right. Right. If you have no question, then maybe we look at the next one. No more question on polar. I think we will just proceed with maybe one more question. I'm not thinking of talking about surface area today. So maybe we can look at one more question. Okay, we look at parametric. Maybe we can have a look at question number 7a. Question number 7a. Have you done? Question 7a, which is November 2009, paper 1, question 8. Okay, we do one more. But it's not polar curve, because polar curve, not many questions. So we have the equation C1 given by y equals to, y is equal to negative ln bracket cos x. Okay, show that the length of the arc C1 from the point where x equals to 0 to the point where x equals to 1 over 3 pi. So from x equals to 0 to x equals to 1 over 3 pi. They ask you to show that s is equal to ln 2 plus root 3. So I'm not going to complete this whole question for you, but I will tell you how to simplify this. So you have, because the most important thing is to simplify the square root thing. So you have dy dx. So remember, when you differentiate ln, especially negative ln, so you have negative 1 over bracket, differentiate whatever inside the bracket. So you have 1 over cos x, then you differentiate cos x. So this one, you will get negative sine x over cos x. Therefore, you get positive tangent x. So that is dy dx. Then after that, the next question is you have 1 plus dy dx squared. So 1 plus dy dx squared, that would give you 1 plus tangent square x. So therefore, 1 plus dy dx squared in the square root is equal to square root of 1 plus tangent square x. What is this actually?
Secant
1
square.
plus tangent. Okay, so you know that this one is actually square root of secant square x. So to integrate, okay, wait. Square root of secant square x is actually secant x. By right, you should have positive lah. You should have the modulus here. Okay, by right, you should have the modulus here. Okay, because the square root of a squared is equal to a. But in this question, even if you don't put modulus, you straight away give me the answer secant x, we accept it. Why? Why we don't have to worry about the negative sign? Okay, because the real reason is because, you see, the actual limit is from x equals to 0 to 1 over 3 pi. Okay, x equals to 0 to 1 over 3 pi. In this region, secant x is more than 0, right? So when secant x is more than 0, therefore you only have the positive sign. You don't have to worry about the negative. So in the exam, if you don't put this part here, it's okay. It's okay. You give the answer square root of secant squared x equals to secant x. But in reality, square root of a squared is actually modulus a. Sorry, modulus is missing. Square root of a squared is actually modulus a. So you see, secant x means 1 over cos x. You need to be careful. You need to be careful because you have to check whether it is positive or negative. All right. So in this case, because of the limit x is equal to 0 to x equals to 1 over 3 pi, both values the secant x is positive. So therefore, you can just ignore the negative sign. So in the exam, for those who are always confused, right, you don't have to worry. Always take the positive, that is correct. Because otherwise negative, they would stay. All right, or they won't ask you a question where the negative region is considered. They don't. But in reality, you should consider. All right. So the next question is, how do you proceed with the arc length? So you see, the arc length is therefore given by what's the limit? 0 to 1 over 3 pi. So you should consider 0 to 1 over 3 pi. Then you are supposed to integrate secant x. Okay, can you tell me how to integrate secant x? Once you know this part, then the rest I leave it to you.
Use ln
Ln what?
1 over cos x.
Huh? Use ln?
In the because secant x is equal to 1 over cos x, right?
Yeah.
So use
Yeah.
the ln, right?
So you mean you change this one to 0 to 1 over 3 pi, 1 over cos x dx. But if you want to use a ln, you must make sure you have this, f prime over f equals to ln f. Then only you can use. In this case, the differentiation of cos x, which is negative sine x, is not on top of it. So you cannot use ln. But the final answer is in terms of ln. Okay?
But we can add anytime, isn't it? Add ourselves.
Actually, you can use the formula list MF19. Do you realize that? Okay, I think I seldom talk about this one. The integral of secant x is actually given in formula list MF19. Okay, you can have a look at page. Okay, so I would like to use this opportunity to tell you actually for secant x and cosecant x both are given. Can you see? Page 6. The first formula for the integral of f of x. That means if your f of x is secant x, you will get ln of secant x plus tangent x. Or you can also say this is equal to ln of tangent bracket half x plus 1 over 4 pi. It doesn't matter. So you can use ln secant x plus tangent x. Whereas for cosecant x, for cosecant x, if you integrate, you get negative ln cosecant x plus cotangent x. Okay? So I seldom talk about the two formula here, the secant x and cosecant x, but I want to tell you, actually the integral of secant x and the integral of cosecant x are both given in list MF19, page 6. So you refer to this one and you will get the answer. Okay? So why do you get the answer? The reason is because they are multiplying the secant x up and down by the integral, by the integrand. All right, so you have secant x. So this is going to multiply by secant x plus tangent x. That is the technique. Divided by, this is the fastest way. Secant x plus tangent x dx. You see, this is actually equal to what? This is actually equal to secant square x plus secant x tangent x divided by secant x plus tangent x dx, 0 to 1 over 3 pi. So if you look at this, now you can use the f and also f prime formula. You can use this one. So what is the f? The f is actually secant x plus tangent x. This is the f. Then where is the f prime? So all of you know that when you differentiate secant x, the differentiation is secant x tangent x, which is here. And the differentiation of tangent x is actually secant square x, which is here. So you see or not? So the top part is actually f prime. So therefore, you can now use the formula. This is equal to ln of the bottom, secant x plus tangent x from 0 to 1 over 3 pi. Okay, now in this question, even if you don't use the modulus of secant x plus tangent x, you are still correct. Why? Even if you don't use this one, you use bracket, because some people like to use bracket. If you use bracket here, it's still correct. Why? Because if you look at the two limits, secant x is 0 to 1 over 3 pi, tangent x is also 0 to 1 over 3 pi. Both of them are positive values. So you know that inside this bracket here is always positive. So even if you don't use the modulus notation, it's still okay. All right. And therefore, the rest, I leave it to you to complete. All right. So that's all. All right. So this is the class for today. Thank you.
Thank you, sir.
Thank you, sir.